Largest area of an isosceles triangle inscribed in a circle of radius 1. We have a circle of radius 1. Radius 1 here. Now we have a triangle inside that. This is an isosceles triangle. Let me draw the triangles. For example, this one, the triangle inside this circle. And you see that it has to be this way. The two lengths are equal. So another case it can happen is if I bring this up here. Say for example here. So in the first case, if I connect this is the radius of length 1. This length from the center to the base of the triangle. This length I call x. So the height of the triangle, let me denote by 8. 8 equal to 1 plus x. Now, if I do the same for the second case here, the distance from the origin or from the center to the base is x here, or x prime. So the height will be this height. This is the radius minus this x prime give us a height. So height 8 in this case, or height in this case 1 minus x prime. So you imagine this case as if x is negative. So for example, if x is negative, x, then this length will be here, so it will be x prime. So x prime, think of that as minus x if x, the first case, negative. So x run from negative, can be negative up to negative 1, positive up to 1, but it can never be either 1 or minus 1, because if it's x here is 1, then you have the height 2, you don't have any triangle at all. If x is minus 1, for example, then that's just a point x between minus 1 and 1. So here I try to write out one formula for the height using just this, so we don't need to worry about two cases. Just use height always equal to that. X here, think of that as the distance between center to the base can be negative. So when it is negative, this covers this case. So 8 here is 1 minus x prime. 1 minus x prime equal to minus x, which will make 1 plus x. So see, that's either way height of the triangles 1 plus x, x between minus 1 and 1. So that about the setup. Now what is the largest area? I need to write out the area. Let's denote by A. Area is equal to 1/2 height times base. Let me denote this length here by y. So we have y bigger than 0, won't be bigger than 0, y in this case bigger than 0. Y half of the base, then the area A equal to 1/2 base times height. 1/2 base equal to y, height equal to 1 plus x, y bigger than 0. So we have areas is y times 1 plus x, which is nice things, but we can even write further. Look at this right triangle. If I connect here, I have a right triangle. I can use Pythagorean theorem to relate x and y. So this length is 1 because it is the radius of the circle. X squared plus y squared equal to 1 square. Note that x squared, y squared, 1 square. And I can rewrite y in terms of x. Y square 1 minus x square, because I have a condition for x here. Remember that. Now square root both sides. Y is only positive, we don't need absolute value. Square root 1 minus x square. So area then will be square root 1 minus x square times 1 plus x area. I can write a bit further like 1 minus x square 1/2 1 plus x, so we need to do derivative. We need to compute critical point. A of x, a function in x between minus 1 and 1. This is the area formula. And in this question, we try to get the largest areas. So we try to maximize this area. Objective: maximize AX, x between minus 1 and 1. Now we know the function, we know the interval, we can find the maximum of that function. Let's do that. A prime of x, I use product rule. 1 minus x squared 1/2 prime 1 plus x plus 1 minus x squared 1/2 times 1 plus x prime. So we have 1 over 2 1 minus x squared minus 1 over 2 times this one prime, so minus 2x 1 plus x. So that is for the first one. Second one, we have that because 1 plus x prime is 1. Now a prime is this, so 2 and 2 cancel out. Minus x 1 plus x square root 1 minus x squared, because it's negative here. Then we have square root 1 minus x squared. Common denominators. Here we have minus x squared plus 1 minus x squared minus 2x squared minus x plus 1 over 1 minus x squared. factor this. Minus 2 minus 1. I know that x, so ax squared bx c. In our case, a is minus 2, b minus 1, c 1. If I have a minus b plus c 0, in our case look like this: minus 2 minus 1 plus 1, 2 plus 1 plus 1, which is 0. So here the trick. If we have this case, then we know that x equal to minus 1 is a root. Why is that? Because minus 1 satisfies this. Minus 1, a times minus 1 squared, b times minus 1, c equals 0. A minus b plus c 0. So that's why it is minus 1 a root. So that means that we can factorize x minus 1, x minus 1, x plus 1. We have this and something, multiply something. So this one now become minus this one times what? Two solution to root a x1 x2 equal to c over a. C is 1 minus 2 minus 1 half. So we know x1 is minus 1, x2 minus 1 over 2 minus that. So plus is 2 times x2 equal to 1. 2x2 minus 1, 0. Here's I have the other factors. All of this is, you don't need that. You can solve this by delta, the formula you know. But with that, I have this one will give me this first one and this second one. X, the first one, x plus 1, 0. But we have negative sign. Minus x plus 1, 2x minus 1. Let's verify what I did. Minus 2x squared minus x, 2x minus 1. So which is minus 2x squared minus x plus 1. Perfect. Here we factor that. A prime is 1 minus x squared here. On top you have this. I want this formula because I know these terms equal to these terms. Now a prime of x equal to this one equals 0 if and only if, or if we want to write a bit nicer, let's try to bring that minus in. A prime of x plus 1, 1 minus 2x, 1 minus x squared equal to 0 if and only if x equal to minus 1 or x equal to 1/2 as I did before. Minus 1, 1/2, but I factorize so that I can see the signs whether it's negative or positive, because we need to check the max or the mean. In this case we do the maximum area. So let's draw that table. X from minus 1, 1. Critical point -1. No, we don't do that. So 1/2. A prime is not defined as this. This one not defined. This one not defined there. This one 0 here. AX. So now with this formula, you see that's always positive down there. So it really depends on the sign here. So if we want to write the two terms, let me write the two terms. X plus 1, 1 minus 2x. So in this case, we don't do anything with this two borrowing. This one's 0 here. So x minus x plus 1 negative here, positive if x bigger than -1. Negative, but we don't care about the rest, so we only care about this part. Positive, positive. This one will be positive, negative, because 1 minus 2x. 1 minus 2x. So I have a trick when I do on this side. Left of the place where 0, on the left is opposite of the coefficient of x. For example, coefficient of x is -2. Opposite with that is positive. Negative here is positive. On the left is opposite. On the right is agree. On the right minus. Here's 0 here. So on the left of the linear terms, opposite. On the right is agree. Anyway, you don't need to know that. You can have this. Look at x. For example, if x less than 1/2, 2x less than 1, 1 minus 2x positive. So that's explain why positive here. And similarly, you can do the negative. A prime of x is the product of this divided by this. So really depend on this. Positive times positive divided by positive, 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 negative. So make it negative. So you see that increasing, decreasing. So we have a max there. Area AX is max when x equal to 1/2. What did they ask us? What is the largest area? They want us to find the area. Area given by this formula. A 1/2, which is a max area. Max area square root 1 minus 1 over 4 times 1 over 2, 3 over 4, 3 over 2, 3 root 3 over 4. This is a max area. That is our final answer.